What geological mechanisms cause singing sand dunes? Imagine standing on a vast desert, hearing a deep hum or a booming sound coming from the sand. It might seem like the dunes are singing, but there's a fascinating science behind this natural music. The reason why some sand dunes produce these sounds involves a combination of the sand's properties, the shape of the dunes, and how the sand moves during avalanches. When sand grains slide down the steep side of a dune, they collide and rub against each other in a synchronized way that creates vibrations. These vibrations travel as surface waves through the sand and then into the air, producing the humming or booming sounds we hear. The grains themselves need to be well-rounded and smooth, usually between 0.1 and 0.5 millimeters in diameter, often made of silica. Sometimes, these grains have a thin coating called desert glaze, formed by repeated wetting and drying, which helps them stick and slide in a way that supports sound production. The shape of the dune also matters. Large dunes with steep slopes, around 30 to 35 degrees, are more likely to sing. When the slope becomes too steep, sand avalanches occur as grains slide down, colliding at about 100 times per second. These collisions cause vibrations that become rhythmic and loud. The vibrations move through the sand just below the surface, acting like a giant natural musical instrument. The dune amplifies these vibrations, making the sound louder. Environmental conditions also play a role. Dry conditions help because moisture dampens vibrations, and air cavities between grains can create resonance chambers that boost sound. Wind can trigger or intensify avalanches, but the best singing happens when the air is still and the sand is dry. The sounds produced are usually low-pitched, between about 95 and 450 Hz, sounding like a drum beat or a hum. The exact pitch depends on the size of the grains, the shape of the dune, and how fast the grains slide. So, singing sand dunes are a natural symphony created by the physical properties of sand, the shape of the land, and the movement of grains during avalanches. This shows how Earth's landforms, like deserts and dunes, interact with natural forces such as wind and gravity to produce these incredible sounds. Learning about this helps us see deserts not just as empty spaces but as places full of fascinating natural phenomena that connect landforms to sounds and movement.